just like Sherlock Holmes, whatever remains must be the truth. And here I see people completely excluding any discussion on the possibility of objects manufactured by other civilizations. And to me, this approach is anti-science. And the way that the mainstream tries to suppress deviance, ideas that are different from the beaten path, is by claiming that it's an extraordinary claim and therefore we should not fund any more research on this subject.
Welcome back to the Information Theory podcast. So I've got to start with a quick apology. This interview has been sitting on the shelf for a long time now. That's completely my fault, but better late than never, and I'm really excited to finally share it with you. Today's episode is a conversation I had with astrophysicist Avi Loeb. Avi's had a remarkable career. He was the longest-serving chair of Harvard's Department of Astronomy, among many other honors that put him at the pinnacle of his profession. Yet he's also willing to advance hypotheses that are quite controversial, even among his peers. We talk about the existence of alien intelligence, the eventual fate of our solar system, and the ways in which the academic establishment suppresses innovation. I ask him whether he has seen any evidence that the US government has stashed away alien technologies. Unfortunately, his answer was no. The thing that really struck me while preparing for this interview was just how prolific Avi is. At one point, he mentioned that we could talk about some of the articles he's written on Medium. So I went and checked, and it turns out he's been publishing around 250 articles a year for the last 5 years. That's on top of his actual day job, his academic work in cosmology and astrophysics, and the books that he's written. Needless to say, I only had time to get through a small fraction of those Medium articles. We start by discussing Oumuamua. That's the name of a mysterious object that was first spotted by astronomers in 2017 from a Hawaiian observatory. And here our interview begins. So I'm sure you're sick of all the Oumuamua questions, but
no, you can ask me anything.
Okay, so let's talk about Oumuamua. What made Oumuamua so unusual compared to the other objects we've observed? And maybe we can start with the story of its discovery.
Right, so Oumuamua was discovered just because it came close to Earth, and there was a telescope in Hawaii called Pan-STARRS that was funded in order to find near-Earth objects. The US Congress tasked NASA in 2005 to find more than 90% of all the objects bigger than 140 meters that could have a devastating impact if they were to collide with Earth. They would destroy an urban area and release more energy than the biggest atomic explosions that we can generate. And so
this is kind of like the asteroid that ended the dinosaurs. They were just trying to find the next one.
They're called the killer asteroids. And there was a recent alert about an asteroid called 2024 YR4, and it had a 3% chance of colliding with Earth. I thought that would be a great opportunity to promote science because young people would enter science to save humanity, and they would find ways to deflect it. I mean, obviously it's not too difficult if you detect it early enough, because at a great distance, a small deflection would bring it away from Earth. So at any event, what we did in the past was wait for radio signals, which is just like waiting for a phone call at home, and a better approach is to look for any objects that may have been manufactured by technological civilizations out there that came into the solar system. And the first one that was discovered was Oumuamua, this object that was found as a near-Earth object on October 19, 2017. Everyone expected it to be either an asteroid or a comet, a rock or an icy rock. It wasn't either because...
So just to set the context, it was immediately recognized as an interstellar object, which in itself is very extraordinary. It was actually the first one ever observed, right?
Right.
And so could you just explain in astronomical terms what that means to be an interstellar object?
Right. These are objects moving too fast to be bound by gravity to the sun. So the size of the object was of order 100 meters and bigger than Starship, our biggest rocket, so to speak. And nevertheless, the
so 100 meters is like a football field.
A football field, yeah. And it had a weird shape because as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10.
So had it been perfectly spherical, it would have just had a constant
brightness, but instead the brightness changed by a factor of 10, meaning that the area projected on the sky that reflects sunlight changes by 10 as it's tumbling. And the best fit to the variation of reflected sunlight was that of a flat object, like a pancake, at the 90% confidence. So that's unusual. It's a very unusual rock if it really is a pancake-like structure. But moreover, it showed that is one unusual feature of it. But it was also displaying a push away from the sun by some mysterious force. So then people said, "Oh, okay, well maybe it's not an asteroid, just a rock. Maybe it's a comet." But there was no cometary tail, no carbon-based molecules around it, no dust, no reflection of sunlight from.
So the three standard explanations of something through the skies, it's either an asteroid, a meteor, or a comet, right? Or it's like a spaceship or something. Like, could you
Well,
explain...
the last one is not at all considered by.
Well, it could be our own. It could be our own spaceship.
Oh yeah,
Like,
it could be our own, and there are examples actually. On the 2nd of January this year, 2025, there was a report by an amateur astronomer about a near-Earth object, and then it was classified as an asteroid, a rock. But then 17 hours later, some astronomers recognized that it has exactly the same trajectory as the Tesla Roadster car that was launched by SpaceX in 2018, and obviously technological in origin. The same happened in September 2020, where that was 3 years after Oumuamua was discovered, and the same telescope in Hawaii, Pan-STARRS, discovered an object pushed by sunlight. And then a few weeks later, they realized, that's just an upper stage of a rocket booster of a NASA launch from 1966. And it had thin walls. And that's why it was pushed by reflecting sunlight. And I actually, without knowing about this 2020 SO object, because it happened 3 years later, I suggested that Oumuamua is reflecting sunlight, we know that, and it's being pushed by sunlight, the same way that this 2020 SO object was recognized as being pushed by. But
so the way that works is the photons from the sun hit the object and they're reflected off, and that's what gives the push, right? So that does that only work if it's very reflective, or could it happen with like a dark material as well?
Oh, it happens for any object that is reflecting sunlight, or
so it has to reflect,
or even absorbing sunlight.
Okay.
But the force acting on the object depends on its surface area per unit mass.
So the force would be normally it would be very, very small for any given object relative to things like the gravity of the sun.
Right, and in fact there are 14 dark comets that were announced by a group of astronomers just a few months ago, and my point is some of them may be space trash that our civilization produced. For example, one of them passed near Earth and near Venus exactly when the Soviets launched a spacecraft towards Venus. So there are a few examples of technological objects we produced. The question is who produced Oumuamua, and to me it opened the window to a whole new realm of detecting extraterrestrial civilizations. And there was another object with my student that we discovered that collided with Earth. It was a 0.5 meter in size, detected by US government satellites, and appeared as a meteor. It produced a fireball as a result of its friction on air. And it again, how do we identify interstellar objects? These are objects moving too fast to be bound by gravity to the sun. Okay, so the local escape speed from the solar system is 42 kilometers per second. And any object moving faster than that, at the distance that the Earth is from the sun, is unbound to the sun. And if we find such objects, Oumuamua was definitely one of them. The meteor was another. The meteor was actually moving faster than 95% of the stars.
So I want to talk about the meteor, but before we move on, you mentioned Oumuamua had all these anomalous properties. It had this trajectory. It had this indication that it was irregularly shaped. So how did you get from there to the idea that it could be an artificially constructed light sail? Could you explain that chain of reasoning, and then also what exactly a light sail is and your previous experience with them?
So a light sail is the ultimate use of push by photons, by radiation, for propulsion. Now, this object may not have been designed as a light sail, but it could have been a light sail because, for example, Freeman Dyson in the early 1960s suggested that advanced civilizations might want to harvest most of the light coming out of their star instead of the Earth using, when we talk about solar power, we are, even if we cover the entire Earth with photovoltaic cells, we would use only one part in 100 million of this output from the sun. So Freeman Dyson said maybe some advanced civilizations would build a megastructure around their star, and the only practical way of doing that is to have light sails. These are very thin membranes that are being pushed by the starlight such that that push is balancing gravity. So they just hover like kites, like a kite above the star. And you can put a whole array of them, a network, to use the light from the star as a Dyson sphere. That was his idea. And now imagine the star evolving and becoming brighter. The sun will become brighter in a billion years. And as a result, the star may break up the Dyson sphere around it after a billion years or a few billion years. And that would basically push all the pieces of the broken Dyson sphere into interstellar space. So maybe Oumuamua was one of these pieces if it was designed as a light sail, but it could have been also a surface layer of a spacecraft, something that was torn apart, or an empty trash bag, carried out of a planetary system. Just think about all the space trash that we have around Earth, the satellites, the broken pieces. They will be carried away out of the solar system when the sun becomes much brighter within the coming billions of years. So you can imagine civilizations producing space trash, and some of it may not even escape from the planetary system, but will eventually be pushed out of it by the evolving star, by the wind coming from the star, the radiation coming from the star. So I'm just saying it could be space trash, or a light sail. It doesn't matter. The point is, I was forecasting that it's pushed by sunlight, and then 3 years later, they realized here is another object. And so my point is, we should be open-minded to that possibility. And nevertheless, what you see from the scientific community is a complete dismissal of that possibility, saying, we can think of rocks that we have never seen before, like comets that release gases that are transparent. So I claim the emperor has no clothes because I don't see any evidence for the cometary tail. They claim, you just can't see it. And I feel like the kid in Hans Christian Andersen's tale. But I'm just trying to be honest about the possibility. And they say, well, it requires an extraordinary evidence to even consider that possibility. And I say, why? Why do we have we should get as much data as possible on the next object with that possibility in mind.
Yeah, so to be clear, the set of possibilities, they're divided into it's either naturally occurring or it's artificially constructed. Right. And you're saying there just isn't anything that we know of naturally occurring that would fit these observed properties, right?
Right. So what people say is that, we have never encountered it before, but we can imagine an iceberg made of hydrogen, an iceberg made of nitrogen. And I say, well, how do you make such an iceberg? We don't know if nature makes it. And they say, well, maybe it's made in molecular clouds. And I say, well, then it wouldn't survive the journey. And they say, oh, yeah, right, it wouldn't survive the journey. Okay, so maybe it's a nitrogen iceberg, which is chipped off a planet like Pluto. And I say, well, we haven't seen such chips in our solar system. And they say, oh, well, maybe it came from another star. And I say, well, the mass budget of Plutos in the Milky Way galaxy is not enough to give you enough such chips. And they say, oh, no, forget about that. And then another group says, well, maybe it's a dust bunny, a collection of dust particles 100 times less dense than air. And I say, well, that wouldn't survive coming close to the sun. And, so the scientists say, we can think of things that might have been produced by nature. And I say, well, if you can think of these things, but we don't know if they survive or exist. And in the context of that, we should also consider artificial objects. And why would there be a taboo on even discussing it?
So of these kind of compelling, of these alternative natural explanations, what do you think is the most compelling one?
Well, I would, I have issues with all of them. I would say maybe if you make an object, let's say, out of the disruption of a planet like the Earth, near a common star, like a dwarf star. Most of the stars in the Milky Way galaxy or beyond are dwarf stars. They are about a tenth of the mass of the sun and a tenth of the radius of the sun. So they're actually denser than rock. They're 100 times denser than the sun. And if you bring a planet like the Earth close to them, there are a variety of dynamical processes that can do that, then the rocky planet would be spaghettified. You will end up with a stream of molten lava from the rock, because that happens close to the star. And then you can potentially get very weirdly shaped objects out of that stream of molten lava. Perhaps you can get something that is looking like a pancake. And then, if it's thin enough, you might get enough push by sunlight, but it's really challenging to get that, I think.
Mm-hmm. So there's this thing that's often been said by the people who are critical of these artificial origin hypotheses, that extraordinary claims require extraordinary evidence. And the way I understand that is, if you think about Bayes' theorem and like a Bayesian framework of evaluating things, you have your prior probabilities. And if your prior probabilities are very low for extraterrestrial existence of extraterrestrial intelligence, then that would require pretty significant evidence to move those probabilities,
well,
right?
But if you are to produce such priors, you will not seek the evidence. If you are thinking in your head that we are alone, that there is nothing smarter than us, okay, out there, then you would say, we shouldn't fund the search for technological signatures, which is pretty much the mindset of astronomers right now. In the decadal survey, they decided to allocate, the funds more than $10 billion to the next big observatory in space, and that will be completed hopefully in the 2040s, and that is just geared towards searching for microbes. And I say, why allocate, tens of billions of dollars just for the search of microbes while dismissing the search for technological signature? We should dedicate similar amounts of funding to both tasks, because that's a way of hedging our bets. If we find technological signatures, they might be much clearer and less disputable, because finding gases like oxygen, methane, CO2, water in the atmospheres of planet will just give us a hint that maybe they were produced by microbes, but it will not be conclusive. And if we find a gadget from another civilization, that could be very tangible evidence. So the point is, when claiming that other extraterrestrial technological civilizations are unlikely to exist, what is really happening is scientists are using it to say no funding should go to that search, meaning we should allocate tens of billions of dollars just to search for microbes, because we don't believe that someone as smart as us exists out there. And I said, that's a mistake. We should allocate, at the very least, 10% of our budget to the search for technological signatures that are very distinct. So even in the context of gases in the atmospheres of planets, we should consider the possibility of industrial pollution. The CFC molecules that we are producing by refrigerating systems here on Earth, maybe they exist on other planets. That is not appearing in the narrative for the next big observatory. So my point is, unless you are seeking the evidence, arguing that it's extraordinary, that you need extraordinary evidence, is really misleading, because
it's a self-fulfilling prophecy.
It's a self-fulfilling prophecy, and it's a way of maintaining our ignorance. And by the way, I don't think that something like us is extraordinary at all, because we exist on a planet and we pretty much have a good idea of how life came to exist on Earth through the chemistry of life in liquid water. We even found the amino acids that are responsible for life, most of them, on the material brought from the asteroid Bennu by OSIRIS-REx. And so we can imagine a completely natural process that made us here today on a planet that is very common in the Milky Way galaxy. There are billions of planets like the Earth in the Milky Way galaxy at roughly the same distance from a star like the sun, at least that many. And that means that you roll the dice billions of times, it's very likely that something like us existed billions of years ago. Now, if we keep insisting that it's extraordinary, we won't look for the evidence. I say, let's put billions of dollars. And I even asked Elon Musk to contribute for that in a recent bet that I made with him. After Peter Thiel said, never bet with Elon, he said that after the election, and the following day I placed a bet and said, I'm willing to bet that we are not alone, and if Elon puts 1% of his net worth, and I will put 1% of my net worth, but maybe in the next decade we might find the evidence, and I'm willing to give him another 1% of my net worth if he is right that we are probably alone. And actually just a couple of weeks ago, he appeared on a podcast where he said that we should search for for the technological relics of alien civilizations. I found that amazing because he didn't say that a few months ago. He said that a few weeks ago. So, as Oscar Wilde said, imitation is the sincerest form of flattery.
Well, I mean, I think you're the one who pointed out that's not the full version of that quote. Okay, well, we can leave it at that. So before Oumuamua, you'd already published numerous papers, as you alluded to, right? Kind of related to the search for extraterrestrial life. So you explore topics like detecting artificial lights from exoplanets. You know, there's this thought experiment: is something like Tokyo visible from Earth if it were on Pluto? And you talked about you had papers about industrial pollution in alien atmospheres. So could you walk us through how your interest in this area developed, and how were these papers received by the scientific community compared to how your Oumuamua hypothesis was received?
Well, I think the reception within the scientific community is proportional to the level of attention that the public gives to the papers. The paper on Oumuamua was even cited by Michael Smerconish on CNN verbatim. He just read parts of it. As long as the public does not respond and shows great interest, then there is no source of jealousy within the academic community. Once the public gets really excited, jealousy drives the pushback from within the scientific community. That's a very simple mechanism. And I noticed this clear trend or correlation. I don't really care because it's not about me. It's about recognizing our place in the universe. It's much bigger than me, this subject, and I'm willing to have all the bruises on my body that result from that. And I should tell you that I get a lot of positive feedback from the public. Just this morning, I signed a few photographs sent to me by someone who follows the work, and I went to visit Sir Richard Branson in Necker Island over the past few days. I just came back last night, and I gave a talk there about my research, and some attendees of that summit told me that they came to it just in order to hear the latest updates about my research and meet me in person. So there is a very large community of followers. Another interesting tidbit, a few months ago I get an email from a girl in Germany who says, I just watched your Netflix documentary about the expedition to retrieve materials from the first interstellar meteor. And I said, no, you couldn't have seen it because it's not out yet. It will come out within a year. And she said, no, I had seen it, and here is a photo of my television screen showing you on the 4th day of the expedition. And I just saw it, and in the middle of that video, I decided to contact you, and because I really wanted to let you know that you should keep pushing this frontier and that you have millions of followers. And the reason I saw it is because I'm a member of a club that is giving feedback to Netflix prior to their release, and so that was quite remarkable that she did that. And so I get and there was an artist, the most accomplished sculptor in the U.S., Greg Wyatt, who donated a sculpture of Galileo Galilei to my office, made of bronze, just a month ago. And every day that passes, I get a lot of emails and responses that encourage me to keep up with this. And as a result, I don't really pay attention to those who introduce toxicity to the conversation, because if you don't want to get dirty, you shouldn't mud wrestle. Many of these scientists, they get into the limelight by attacking what I'm doing, and I view that as mud wrestling rather than chess playing. And I used to, metaphorically play chess when I worked on cosmology. I should say back then, there wasn't that toxicity. But when a subject like that resonates with the public, immediately you get this pushback. It comes with the territory, and I accept it.
Yeah, so to be clear, because all the previous papers about things like industrial pollution by aliens did not receive nearly as much publicity, accordingly, there wasn't any pushback. Right. And then I guess after you published your paper, there wasn't pushback, but I think you mentioned that immediately after it became viral in the news media, that's when the attacks from other scientists began.
Exactly. And it's not just attacks in the media when people are quoted as saying negative things. It's also the attempt to suppress the publication of scientific papers by those critics who don't want it to show up academically. What about free speech in the scientific realm? If you look at cosmology, we don't know the nature of dark matter. It makes 85% of the matter in the universe. When I started my career, there were hundreds of papers about suggesting possibilities for the nature of dark matter. They were welcomed by the open-minded, chess-playing scientific community because we don't know what it is. And, for 50 years, we put a lot of money trying to search for various types of dark matter, and the searches are guided by theoretical work, by ideas. It's good to have a lot of ideas on the table, then you can check them and rule them out one by one. And just like Sherlock Holmes, whatever remains, must be the truth. And here I see people completely excluding any discussion on the possibility that technological signatures might appear in the solar system in the form of objects manufactured by other civilizations. And to me, it's anti-science. This approach is anti-science. And, I have a lot of young people that work with me, and some of them are really traumatized by the behavior of some colleagues because in order for them to get jobs, they have to dance to the tunes of selection committees. But if there is such an aggressive reaction to any idea that is out of the box, they would avoid it, and they would. This basically suppresses innovation, and that's the other fight that I'm trying to have, which is science should be open-minded, and we've seen a lot of scientists making huge mistakes. There were mainstream scientists who claimed that the virus, the COVID-19 virus, could not have come from the Wuhan lab, and they were claiming that it's racist and that people who mentioned that possibility should be cancelled and removed from academia. It was very vicious, very toxic, very aggressive, this response. In retrospect, it may have been motivated by some of the people who funded the research in the Wuhan lab that didn't want this to be discussed. It doesn't matter. The scientists that are in the mainstream signed up for these attacks on that possibility, and now it's being recognized by congressional committees that this is a real possibility. And on any matter related to science, we should be open-minded. We should allow thinking outside the box. There is nothing harmful about those possibilities because they trigger the collection of more evidence. The biggest thrill that I have is from being flooded with data, because once you are flooded with data, it would become clear if the mainstream view is incorrect. The way that the mainstream tries to suppress deviance, ideas that are different from the beaten path, is by claiming that it's an extraordinary claim and therefore we should not fund any more research on this subject. And that's a trick that is being used all the time. When you see mainstream scientists say that something is an extraordinary claim, you have to ask them, are you willing to put a few percent of the budget into demonstrating by collecting enough evidence that these are not valid? That is really the key. And in the context of looking for interstellar objects that might be technological in origin, the funding level is less than 0.1%, 10 to the minus 3, of the funding of the search for microbes. And I say, is that reasonable at all?
Yeah, yeah. No, it doesn't seem reasonable. So you've mentioned your experiences mentoring younger scientists, and you've also written that young people naturally imagine new worlds. So what specific practices can scientists develop to preserve that capacity? And then what specific strategies would you recommend for a young scientist who wants to pursue unconventional research without being marginalized and jeopardizing their scientific career?
Yeah, so by the way, it's not just a matter of a theoretical proposal on my side. It's whoever becomes the next director of the National Science Foundation could implement such an approach to cultivate much more innovation in science. And by the way, that would bring trust from the public. When science is exploring multiple possibilities, doesn't pretend that this is truth that you lecture about to the public when actually you don't know the truth, then I think science will get much more credit from the public. So first thing I say to young people is never pretend to be the adult in the room, because when I was young, I was sitting at the dinner table and asking a difficult question, and it was clear that the adults in the room are inventing stories when they didn't really know the answer. And so we should not pretend to be the adults in the room. We should always be sincere about what we know and we don't know, and be curious. So the childhood curiosity should follow us. And when we admit that we don't know something, we decide to look for evidence that will guide us. So the beauty of science is that it's supposed to be guided by evidence, not by prejudice. Yet you find senior people, just building echo chambers that repeat what we already know and have a narrative. Sometimes the narrative has political aspects to it, as we discussed in the context of COVID-19, that there were political reasons for some people to do that. But sometimes it's just a matter of maintaining the status quo and not, having those echo chambers survive scrutiny. At any event, in terms of a policy, my recommendation is allocating a fraction of the budget of any federal funding agency, any. That includes NIH, NSF, DOE, NASA, deciding about a level of funding that, let's say, 10% of the budget going to innovative, risk-taking projects, meaning we don't know the answer in advance, okay? These are ideas proposed by credible scientists. I'm not talking about, someone who dreams about a flying saucer or about some crazy stuff. I'm talking about credible scientists who are professionals. They really follow the scientific method by suggesting to look for evidence for things which are challenging the mainstream. Okay, so how do you know about things like that? Because you see anomalies. The data does not line up with conventional thinking. So my point is, let's allocate 10% of the budget to studying anomalies, because they represent opportunities for new knowledge. And when these anomalies, if some of them are demonstrated to be mundane, or most of them, that's perfectly fine. But even if 1 in 10, 1 in 100 ends up being new knowledge, it would compensate for all the lost investment. And that is the way venture capitalists, put money forward. They are willing to take risks. And so if it's recognized in the business world, it should be also recognized in science. Instead, what happens is you have committees that are populated by mainstream scientists who are basically supporting their own friends who are following the beaten path. Whatever, echo chamber exists, they keep funding that kind of, even when, for 50 years, We've been searching for dark matter in the form of weakly interacting massive particles. That kind of channel for funding will continue to be funded because the people who decide about it are the people in the community that was doing it for 50 years. Okay, they are not being challenged by people who think differently, and I think that should be broken. And I'm not saying provide most of the funding or half of the funding. I'm just saying we should invest in stocks, not just in bonds. And I actually wrote it in a Nature paper on policy, science funding policy already in 2011. And so that is now you may ask who will serve in these committees. These are the people who should serve on these committees that decide about funding risky projects should be the people who innovate, who have a track record of both doing mainstream work, but also exploring productively ideas that deviate from the mainstream. Some of them got awarded prizes because they made discoveries, some not. It doesn't really matter as long as they are open-minded, okay, and not just funding their own line of research.
So I think the VC model of science funding you suggest makes a lot of sense, but based on what you're saying, it also seems like you're suggesting that a very large percentage of the research currently being done is for things that we do know the answers for
yes,
in advance.
Definitely. I was funded once for a NASA project in which I was asked to forecast what I will discover in year 1, year 2, and year 3. So in order to satisfy the administrators, I said, I basically laid out my expected discoveries based on what I already know. So because I wrote already some papers that were not yet accepted for publication, and I knew that I can calculate those things. But it's a ridiculous funding scheme where you're supposed to forecast. Because basically...
You can't forecast discoveries by their very nature.
Yeah, and what it means is that you will do work that is not really very innovative. As long as you can define what you will find, it's not really very interesting. So why fund mostly uninteresting research? That makes zero sense, in my opinion.
So I guess that makes me wonder, if you had to estimate of your colleagues at Harvard's astronomy department, what percentage of their collective time is spent researching things that are uninteresting, known in advance, just there to further their careerism or an orthodoxy, right?
I would argue
how much actual research is being done that's valuable in your opinion?
I mean, it's not just at Harvard. Knowing my community, because I served as chair of the astronomy department at Harvard for 9 years. I chaired the board on physics and astronomy of the national academies, and I know the community very well. And I would say at the level of I would say 95% on average throughout the community is finding things to a higher decimal point, exploring nuances on themes that were already explored before. It's not really brand new research that is charting a completely new territory. That is extremely rare. Now, every now and then there is a discovery, of something new. When gravitational waves were discovered, that was a new way of doing astronomy that was never practiced before. Obviously, immediately after the discovery, lots of papers were written and lots of proposals were proposed in order to explore it further. Now, you may ask, why were gravitational waves discovered? In 2015, the first discovery. And the answer is because there was an administrator at the National Science Foundation who knew general relativity and appreciated the value of general relativity. Thanks to that one administrator, the LIGO project received federal funding. Whereas the home institution of the person who thought about the hardware that was used to build the experiment, Ray Weiss, the home institution, MIT, did not support him. And I spoke with former president of Harvard, Larry Bacow, who at the time was at the high administration at MIT. And I talked with him about LIGO, and he said, back then, when the project was proposed, The project was asking for funding internal to MIT. And he said, as an administrator, I reached out to the physics department to ask, what do you think about Ray Weiss's proposal? And they told him, don't fund it. It's very risky. It will not find anything. And that's his colleagues within his physics department at MIT going against him. And obviously people outside that department were not willing to fund it. So just thanks to an administrator within NSF, this project got funded and gravitational waves were detected. Obviously, people would say it's an extraordinary claim that we can detect gravitational waves, and therefore it shouldn't be funded. And he pushed it through. That's an amazing feat. It opened a completely new window into the universe. In the past, astronomy was mostly done by detecting light. Now we can use gravitational waves to detect black holes that do not emit any light. They just produce ripples in space-time. So that was a pioneering discovery that obviously led to a lot of grant applications afterwards. But the actual project went through a lot of difficulties to get funded. And in today's climate, my point is NSF would not fund it, for
because
sure.
it's considered an extraordinary claim, basically.
Yeah, NSF would say it's very risky. We don't know if there are sources of gravitational waves. Today, this project would not be funded. And so the question is, how do we bring back the sense of innovation, exploration that was the trademark of physics 50 years ago or 100 years ago? My point is now there are many more practitioners, but less innovation. Mm-hmm. And of course, with the right policy, we can bring it back.
Yeah, I mean, is that maybe, or maybe just the whole culture has changed in a way?
I don't think so. I think young people, I interact with young people, they're extremely excited about innovation. It's just that they are groomed into a mindset. By the time they get tenure, they don't deviate from the beaten path. Because the clergy, just like a religious organization, the clergy keep repeating their mantras. And the young people, by the time they become the clergy, they forgot what childhood curiosity is all about.
Mm. What you're a member of the clergy now, right? You're basically like a bishop, like a local bishop.
Yeah, but I'm just the same as I was as a kid. And you may ask, how did I survive the process? It's because I am not willing to surrender. I always was curious, and I always wanted to ask questions that nobody else asks. And I did serve on leadership positions, but I did it just in order to help my community, my environment, just help it be better. That was a service. It's just like I felt like a server in a restaurant. I'm just trying to help other people accomplish their goals. But now that I finished some of these leadership positions, I can go back to the thing that fascinates me, with his curiosity-driven research and evidence-based research, not listening to, what people claim is the folklore.
Yeah, you've mentioned that after your parents passed away, you felt liberated to pursue more unconventional research. Could you talk about that, or maybe some other events in your life that changed your trajectory in that way?
Yeah, that's definitely true. My father passed away first, but then my mother, I had a very strong connection with her, and obviously she advised me not to go against the wind because it would harm my career. But she passed away soon after I came up with the paper on Oumuamua. In early 2019 she passed away, and I felt in a way that liberated, as you say. For now, what I do is basically what I want to do, and I have a peace of mind. I was attacked soon afterwards, and it bothered me. But now, I'm completely resilient to that because I'm trying to do what makes sense, and And, in the long term, that's what counts.
Mm.
Because if we do find evidence, or if we put limits on the existence of other civilizations, that would serve humanity for many years to come. And we live for such a short time. If we keep paying attention and pursuing likes on social media, we will lose time. And
Mhm.
so I think rather than paying attention to social media, I pay attention to nature.
Yeah. So yeah, then that leads me to IM1. So I want to talk about this object. Um, so Oumuamua was not actually the first interstellar object to have been detected by our instruments, right? There was a meteor called IM1. It entered the Earth's atmosphere, landed in the Pacific Ocean in 2014, but it wasn't until 2019 that somebody noticed. So could you tell the story of IM1 and in particular how the publication of its discovery was held up in peer review until there was some intervention?
Yeah, so in January 2019, I was invited to a radio interview. It was about a meteor that was spotted over Kamchatka near the Bering Sea. And I didn't know much about meteors, so I went online and I realized, oh, there is a website created by NASA, the Jet Propulsion Lab, and they list all the meteors that were discovered by US government satellites. They have a catalog. And when I looked at it, I realized, oh, they give the velocity of all these objects that
And just
collide
to set
with.
the context, a meteor is a rock that enters the atmosphere of the Earth.
Well, it's an object that collides with Earth as Earth moves around the sun, and it burns up in the atmosphere and explodes as a fireball. Actually, once a year, we have a meteor, roughly a meter in size, that collides with Earth. That releases as much as the Hiroshima atomic bomb energy. We have an atomic explosion in our atmosphere, but usually it's at an altitude of maybe 50 kilometers, so it doesn't cause any damage to Earth, and that's why we don't hear about it. And it's just that release of energy, this explosion as a result of friction with air, that can be spotted by US government satellites that are seeking ballistic missiles launches and other things of importance to national security. And so every time they see a meteor that is of origin from outside the Earth, they put it in this catalog because it's not of importance for national security. They think to themselves, the US Space Command thinks that might be of use to the scientific community. And so I asked my student back in after this radio podcast in January 2019 to look through the catalog and see if any of the reported velocities is above the escape speed from the solar system. And we immediately noticed that the most deviant object, which when extrapolating back in time was actually moving at 60 kilometers per second outside the solar system, faster than 90% of the stars near the sun. And we wrote a paper about it in March 2019, submitted it for publication, and then the reviewer said, no, this paper should not be published because we don't believe data that comes from the US government on meteors. And at the time, I was chairing the board on physics and astronomy of the National Academies, so I was complaining about it at an after-dinner presentation that I gave to the board and about this subject. And one of the board members, who at the time was at Los Alamos, said that he would be happy to help. And eventually, I reached out through the White House to the US Space Command, and it took them 3 years to issue a letter to NASA after looking back at the data that confirms that at the 99.999% confidence, this object came from outside the solar system. And at that point, our paper was accepted for publication. 3 years later, okay, it took 3 years. It was published. And then I decided to lead an expedition to retrieve materials from the crash site of this meteor. And we went to the Pacific Ocean. I received $1.5 million, and we boarded the ship that was called the Silver Star. And Netflix was there on the ship, and they documented everything that happened. We collected the materials from the ocean floor using a magnetic sled a sled made that is covered by magnets. And we analyzed this material over the past year at the laboratory of my colleague at Harvard, Stein Jacobson, and we found that about 10% of the materials had very unusual chemical composition. These were molten fragments from very likely a meteoritic explosion. And we are now analyzing the isotopes. Actually, later today, I'm about to participate in a Zoom meeting with the team that works at the laboratory to see how things are going. And if we find some isotopes that have an age very different from the age of the solar system, that would be a clear marker that we found materials from outside the solar system. But for now, we have this unusual chemical composition. And I want to go there again with a robot that we will put on the ocean floor that would collect bigger pieces. I mentioned that to Richard Branson in my recent visit, and I hope that someone would support us. This expedition will cost a few $1 million. And so, that's the way science is done. It's by making the effort. But I should say that at the time that we came back from the expedition, there was a paper published in the Astrophysical Journal claiming, again, that they don't believe the US government data. And after we started analyzing the data, there were papers claiming, oh, you just found coal ash. And we checked, and 60 elements from the periodic table do not show the abundance pattern of coal ash. And another group said, oh, this was not really a meteor, it was a truck. And I just pointed out that we went to the region associated with the fireball, with the light emitted by the explosion. That was 1% of the Hiroshima atomic bomb energy. And a truck cannot produce so much light. It's just crazy what kind of claims people were making. And some journalists attended to these claims and published them. So I'm disappointed not just by the practices of some of my colleagues, but also the practices of scientific journalism, where they don't always, the journalists do not ask for my response before they publish a story. And, it's just a matter of common sense. You have to attend to the facts. And if this is the way they report about science, why should I believe anything they say about politics?
Mm. Yeah, I guess what's encouraging about this story is that the Department of Defense actually stepped in and gave you this push. And so that kind of raises in my mind the question, how much do they actually know that they aren't letting on, right? Did they know about this thing the whole time?
Yeah.
So, we kind of know that the US military has technological abilities that are secret, classified. And we even know that the NSA is probably sitting on some pretty advanced applied mathematics that hasn't been published and, therefore isn't known to the academic community. So I'm wondering, do you have reason to believe that some government agency is sitting on major astrophysics knowledge that isn't known to academia?
Well, there is one office that was established after the Director of National Intelligence submitted 3 reports to the US Congress, and that is AERO, the All Domain Anomaly Resolution Office. They claim they can reach anywhere within government. They saw all the information, all the data, and that there is no clear evidence that any of it represents extraterrestrial technologies. That's what they say publicly. They say 97% of the reports can be easily explained. When I talked with them, they said that there is a small fraction of the reports that appear to be anomalous, and they don't know what they represent. It's not objects that move the way that human-made technologies are able to produce. It's not objects that are natural. So they don't know what these things are. And obviously it could be, atmospheric phenomena that we don't fully understand. It could, be something else. My point is that we should collect data and figure them out rather than ignore it. So the mainstream of the scientific community is dismissing the need to do that. There was a committee by NASA that recommended the need to do that. I co-founded the Galileo project that I'm leading right now, which is aimed at building observatories that would collect more data. And Currently, we are collecting data about 100,000 objects every month in the sky. We have one observatory already functioning at Harvard University. We have two more in the pipeline to be assembled by summer 2025, and another one that will come later, maybe a couple of years later. And my hope is that we will have millions of objects monitored in the sky, and maybe one in a million would look really interesting. And this is not a task that we should expect the US government to fulfill, because they are supposed to be focused on national security. And if they see something that behaves in ways that cannot be reproduced by known technologies that humans made, they might ignore it. It's not their job, And my day job is figuring out what lies outside the solar system. So instead of asking the government to disclose what they know, I think we should just, if it's out there, we can collect it. The sky is not classified.
So the Galileo project, just to be clear, is kind of the scientific effort to collect more data about these UAPs, unidentified aerial phenomena. And the reason that, there's kind of a difference of focus, right? Like the instrumentation that a scientist looking for this kind of thing would assemble is kind of different from what the government would have for military applications.
Yeah, except because it's a scientific project, everything is in the open. They might try to imitate what we are doing and try to figure out on their own things. I don't see that as a problem. I think the way science makes progress is by collecting data. And the worst thing that can happen is what some mainstream scientists are doing, is brushing it aside and ignoring it. Because if there is any evidence for extraterrestrial technologies anywhere, that would be the biggest scientific discovery ever made. So how can we ignore that? It's similar to the argument that Blaise Pascal, the philosopher mathematician, made. He said, we cannot ignore God because, the implications would be huge if God exists. And I say the same thing about extraterrestrial civilizations. I say the implications will be huge. We cannot ignore this idea. And we should fund the search for data that would educate us about what might lie in our cosmic neighborhood.
Mm-hmm. Yeah, you've talked before, you've written before about how, we might, if we were to recover some kind of alien technology, it would kind of really supercharge our own technological advancement. And I'm just wondering, you must have talked to a lot of people in government with top secret security clearances, right? And so, maybe from our own government, we could find things out that really advance our scientific understanding.
Well, believe me, I actually asked this question to officials from Aero just a few days ago. But I'm not signed on any NDA at the moment. They do not give me any confidential information. All they can say is, the general statements that they made before, that they identify 97% of the objects, and there is a small fraction that appear to be consistently appearing, reported by many independent people within the military and the defense system, and more data is needed to figure them out.
So I'm wondering, what would be the most surprising thing that somebody with a top secret clearance would have told you that isn't publicly known through these press releases?
Well, they will not tell me anything because it's classified. But I would actually love to help them figure it out, whatever it is. If they wanted to share it with me, but so far they haven't been open to that.
So they haven't even offered to have you sign an NDA?
No.
Okay. We've been talking about UAPs, and the U.S. government has recently become much more open about this idea of UAP encounters. There have been, Navy pilots describing objects with these really impossible seeming accelerations. Do you find any of these accounts credible?
I think people are sincere. The reports are really sincere. That includes all the congressional testimonies under oath. Whatever people report about, is something they believe in. On the other hand, if you ask, does it reflect reality? That's a separate matter, because if they don't have direct access to whatever the government found, they might be illusioned that it represents extraterrestrial technologies. For example, imagine an office in government that its main task is to search and retrieve wreckage from adversarial countries that are trying to spy on the U.S. or are fighting the U.S. in the battlefield. That makes a lot of sense, right? Because then you can figure out how they produce their own military technologies. And so such an office probably exists. It would make a lot of sense. I don't know where exactly is this office and what its name is, but I would imagine that it exists, because in any battlefield we can learn a lot about adversarial technologies. And so imagine them finding evidence for technologies that the US did not develop as of yet. Okay, they might taint it as with a speculative label of extraterrestrial technologies, just to avoid, if anyone hears about what the US is doing, and they would talk about extraterrestrial, and everyone would sort of dismiss that as unreasonable. So then, if that kind of a label gets to the attention of some administrator or officer within government, they would say, I definitely know that there is an office within government that collected technologies that are extraterrestrials, and that person would be sincere. But the point is that it doesn't reflect anything in reality that supports this claim. And so that's where I'm confused, because I haven't seen any direct evidence for those things.
So in your view, what would constitute compelling scientific evidence? What standards of proof would you apply?
It's very simple. If someone shows me materials from a crash site and claims that it came from from outside the solar system, I can easily check the materials the same way I did with the expedition materials, and see whether there are isotopes that indicate an age different than the age of the solar system. That's very easy. It just costs at most a few $100,000 to do that in the same laboratory where I examined the materials from the crash site of the Interstellar Meteor, IM-1. That's very easy to do. I mean, it doesn't matter whether you say this is an actual gadget that maintains some integrity or not. I can just check the materials, immediately tell you.
So in the absence of material evidence, I guess, what role should physics play in evaluating these reports, right? If some objects are reported moving in ways that violate known physical laws and there's instrumentation that captures it, how should scientists approach such claims?
Physicists should be made aware and then analyze this data, because if what is claimed is true, then one can get a Nobel Prize easily. Physicists work a lifetime to discover new physics. It's really rare and difficult these days. And if there is any clue to new physics, that whoever discovers it not only will reap the benefits of commercial entities that can be spawned out of it, but also, even before that, get the Nobel Prize in physics. And what I'm saying is it's really difficult to advance our knowledge about the physical reality. Most of the Nobel Prizes in physics are given to discover a validation of concepts that were advocated decades ago. Very little new physics is discovered, right now. And so I think any such data should be shared with all scientists, all humans, because it has huge implications for our future. And it will open up a window by which we can learn much more than we currently know. And why hide it? Just think about you living at a home and having your family without even knowing whether you have neighbors. And then you go out to the backyard and you find a tennis ball that was thrown by a neighbor, or an empty trash bag from a neighbor's yard. And then you realize, we actually have a neighbor. Then you sit at the dinner table with your family. The question is, would you tell your family? And my answer is definitely yes, because you cannot avoid this information. At some point, a neighbor will knock on your door or visit your backyard. So you have to tell your family about it, and that's what I think about any government data, that it goes beyond human-made technologies.
Right. And that brings me to the Fermi paradox, right? So the Fermi paradox is the question posed by Enrico Fermi. Where is everybody? Why hasn't there been any neighbors showing up on our doorstep? And so what do you think is the solution to the
Well, I
paradox?
think this question, where is everybody, that Enrico Fermi asked, more than 70 years ago at lunch in Los Alamos, that this is a question that every lonely person asks. And what you tell a lonely person is, you shouldn't be that arrogant and pretentious to think that you're so attractive that everyone will come to you exactly when you're having lunch in Los Alamos, You should be proactive and search for the evidence, especially since space is so vast, in the Milky Way galaxy. The nearest star to Earth, is at a distance of about 4.25 light years, which is it's 10 billion times bigger than the size of Earth, and so just to imagine that they would come and sit next to you, I mean, you are not that important. You should search for them, and it requires telescopes. Enrico Fermi didn't build a telescope. My answer is, seeking the evidence is key for finding it. That's my answer. Now, of course, you might seek evidence in a way that is not very productive, like saying, I want to wait at home for a phone call, and nobody would call you. And that has been the practice of the SETI community, just waiting for electromagnetic signals. And I say we should check in other ways. We should check for objects near Earth that may have been produced artificially.
So,
Yeah.
so there's a set of kind of hypotheses that try to explain the paradox. So have you heard of the dark forest hypothesis?
Oh, yeah, of course, yeah.
Yeah. So it's recently been popularized by kind of science fiction writing, and so the idea is that there's a bunch of civilizations out there. We're all seeking to survive. We don't know each other's intentions, and so the only rational strategy is to kind of stay quiet and not give away our presence to anybody else.
That is definitely reasonable. If you are afraid of cosmic predators, you would try to be as silent as possible. You might even develop high energy accelerators of particles to communicate using dark matter particles that are not visible electromagnetically. You could communicate via waves in dark energy, which is not electromagnetically visible. Our technologies science, modern science, is only a century old, and I can imagine much more fancy ways of communicating, traveling, and so forth than we currently employ. And of course, the other possibility is that just like we are getting addicted to digital screens, they are already addicted to their own virtual realities. Just like people that are high on recreational drugs. Our digital future may be us being completely occupied by virtual realities, not willing to explore the physical reality that we all share in the universe. And if they reach that level of indifference to the rest of the cosmos, if they are also just like we are, focused by down-to-earth matters without looking up, if they don't seek role models that are better than their politicians, we would not see signatures from them because they would perish on their home planet by some natural disaster. Either their star, would destroy life the way that the sun would in about 1 billion years. We just have 20% left for our cosmic lifespan, or they would inflict wounds on themselves in the form of AI systems bringing them to a catastrophe. And so one way or another, these may not be long-lived civilizations, or not civilizations that we can get the signals from because they're self-centered.
So allowing the possibility that some of them might be predatory, or at least that they have weapons technology with which a subset of them could be reckless with. How concerned are you that kind of our efforts to investigate these phenomena or just the fact that we've been broadcasting radio waves out from Earth for over a century. How concerned are you that the detection of our civilization could lead to, predation by other civilizations?
It might well be the case. I mean, I'm concerned, but I'm more concerned about immediate risks, simply because we've been transmitting radio waves for about a century, okay, and they went 100 light years away from Earth, and there aren't many stars 100 light years away. Most of the stars are thousands of light years away. So within a millennium, someone may hear us and come to visit us as a result. So, we have hundreds of years left before we hear back from them. If they move at the speed of light, if they move much slower than the speed of light, it may take millions of years or billions of years. But eventually they might come here, the predators. But there is the thing to keep in mind, the thing that keeps us safe for a while, is the vast distances that would allow us to function as if they don't exist until they show up in our doorstep, and that could happen. And civilizations like ours that were careless might have been annihilated. But on the other hand, it may well be that whoever listens to our signals realizes that we are not that sophisticated, that we don't deserve any attention, because we behave in ways that do not show intelligence. We are not looking up. We are mainly looking down. We're killing each other, investing $2.4 trillion a year on military budgets. We are really not very different than animals. We keep eating animals just because we think that they're less smart than we are. We keep arguing that we are the smartest in the universe. Just think about that. This claim alone, after seeing, that the Milky Way galaxy has hundreds of billions of sun-like stars, and there are 100 billion galaxies like it in the observable volume of the universe. Just claiming that we might be alone is not a sign of intelligence. And that's the mainstream of the scientific community and people who argue outside the scientific community that it's an extraordinary claim to imagine something as faulty as the human mind. I just say let's collect data before we say that. Why should we search for microbes? Let's search for things that are better than us.
So the thing about astronomy is that it kind of makes you realize how small you are as an individual, kind of in both space and time, right? And you write about things like in 1 billion years the sun is going to boil off the Earth's oceans. So how does that ultimate impermanence affect the way you kind of conduct your daily work, your daily life?
Well, we are transient actors on the cosmic stage, and that's true, on the personal level. I will die within a few decades, and I want to leave behind a better world than I found when I came into it. And perhaps it will bring humanity to a better place. And the way I do it right now is by promoting the idea that we are not alone, that we should search for partners. But it's true also of humanity as a whole. We would disappear from the surface of this earth. We might explore space before that, or send ambassadors in the form of AI astronauts, and that will be the only statues that are left from us, monuments left from our civilization that would tell the world, the universe, that we existed. And I don't think anyone might care about it elsewhere. Just the way we ignore the possibility that something like us exists. If they have a similar mentality, most of them would even ignore that. If they find a meteor that is actually a Tesla Roadster car colliding with their planet, they might say it's a rock of a type that we've never seen before. Let's move on, the way my colleagues do. And even if one scientist there says, let's examine it and finds the evidence, and they realize they're not alone, it might not have any cosmic significance, because the universe had much more powerful events in its history, and we are just here for a short while. The Earth will recover from humanity 1 billion years from now until it's engulfed by the sun and disappears into the sun when it becomes a red giant. the sun itself will become a white dwarf. That's a metallic sphere. The core of the sun, 60% of its mass, will collapse to an object called white dwarf that is the size of the Earth, and it will cool and fade away. And so the Earth will be buried inside a metallic sphere. And nothing lasts forever. And we should be really we should feel fortunate that we are actors on the cosmic stage for a while, that we can try and figure it out. One way to do that is by finding other actors who know more about what the cosmic play is about. That's what I'm trying to do. It would save us time.
You've written that each of us is merely a transient structure that comes and goes, recorded in the minds of other transient structures. How do you want to be remembered? Or does it not matter?
It probably doesn't matter, but if some people remember me, I want them to view it, what I did, as bringing a sense of cosmic modesty in our daily life. The fact that we are not the pinnacle of creation, that there is a lot of room for improvement. And we can learn from a higher intelligence in outer space, as well as from a higher intelligence in AI systems that we produce. And so the only thing we need in order to accomplish this goal is be willing to learn. And that's, throughout our conversation, that's all I was saying about the mainstream scientists who think that they know the answer in advance, who argue that some statements are extraordinary claims and therefore they don't want to seek the evidence and therefore we don't have the evidence and therefore we should keep our past knowledge. I'm just saying they don't have the sense of humility that would allow them to learn something new. And therefore, my conclusion is we should fund research that pays attention to anomalies. And that would accelerate the rate of innovation and acquiring new knowledge. And it's sort of a sense of indefinite childhood curiosity, because children, are not attached to their ego as much as adults, and they're willing to learn. That's the entire thing they're doing. If they see something unusual, they go to that thing and play with it, try to figure it out. That's what babies do. Because when they play with it, they learn more about it. An adult would look at it from a distance and try to save time and just ignore it. And so my point is, let's look at nature like children and always willing to learn.
That's great. All right. Thank you, Avi. This has been a really, really interesting conversation. Thank you for your time.
Thanks for having me.
I hope you enjoyed our conversation. If you want to learn more about both sides of the Oumuamua controversy, I'll link the relevant journal papers in the show notes. But honestly, for a much more enjoyable read, check out Avi's best-selling book, Extraterrestrial, which I had a lot of fun reading. And once you're done with that, you can read the follow-up book, Interstellar. Thanks for listening to the Information Theory Podcast.